This video we are going to learn about the MCQs related to solutions and mixtures. Which of the following statement about solution is incorrect? A solution is a homogeneous mixture. It is true. It is a homogeneous mixture. The solvent is always the component in the largest amount. It is also true. Solute is in the smallest amount, so solvent is in the large amount. Adding solvent changes the number of moles of solute. This is wrong, because if we add solvent, it doesn't change the number of moles of solute. Moles of solute always remains the same. Molarity expressed as the concentration as mole per unit liter, so that is molarity. That is also right, so our option is going to be C. Then next question, a chromatogram of two compounds A and B is shown above. The RF value of compound B is, so RF value is calculated by distance traveled by solute, distance traveled by solute divided by distance traveled by solvent front, traveled by solvent front. So solvent front distance is this much, which is 8 centimeter, and compound B has traveled 5.2 centimeter. So 5.2 is the distance traveled by solute, and distance traveled by solvent front is going to be 8. And after solving it, the answer comes out to be 0.65. So our right option is going to be C. So in the next question, they are saying the distance that an amino acid moves on the chromatograph depends on. So first of all, it depends upon the size. First thing is going to be the size of amino acid. This is going to be the first thing. Second is going to be the polarity of the amino acid. Polarity of amino acid. If it is more polar, then it can travel more further. Then third is going to be the solubility of mobile phase. Solubility of amino acids in mobile phase. If it is more soluble in mobile phase, then it can travel more further. Compared to what? It is compared to its adsorption, on stationary phase. So all these parameters contributes to the intermolecular forces between the amino acids and both the mobile and stationary phases. So our right option is going to be B. So in this question, they are saying which of the following describe the correct procedure to prepare 0.25 liter 0.1 molar Na2CO3 aqueous solution. So first we are going to find the number of moles. Moles is equal to molarity times volume. So molarity here is going to be 0.1 and volume is going to be 0.25 liters. So it comes out to be 0.025 moles. And then this is the molar mass given, and we have to find the mass. Mass is equal to mole times molar mass, mr. 0.025 is the moles, and this is 106, and the answer comes out to be 2.65 grams. So our right option is going to be B, because it is saying dissolve 2.65 grams of Na2CO3 in a small amount of distilled water and dilute to 0.25 liter because the mass of Na2CO3 should be added to a small portion of water and then diluted to the desired final volume. So that is why our option is going to be B. The reason that I can also write that because the mass of Na2CO3 should be added to a small portion of water and then diluted to the desired final volume This is the right procedure. So that's why our answer is B. So in the next question they are saying a 5.23 gram sample of anhydrous potassium sulfate is dissolved in 1.75 liter of solution. What is the molarity of the solution? So first we are given with the mass. So first let's find the number of moles. Mole is equal to mass by molar mass. Mass is 5.23 and molar mass here is going to be 174.3 of anhydrous. So that comes out to be 0.03 moles. And then we have to find the molarity. The formula of molarity is mole divided by volume, which is going to be in liter. Mole is 0.03, liter is 1.75, and that comes out to be how much? That comes out to be 0.0171. So our option is B. So in the next question they are saying which of the following solution contains the greatest number of moles of chloride ions? So first of all we need to use the formula, that is mole is equal to molarity times volume. But let's say we are doing it for A part. Let's do it for A part. Molarity is going to be how much? That is 0.1. And volume is how much? That is going to be 25 milliliter, but we have to convert it into liters. So divided by 1000, it comes out to be 0.025 liter. Now we have to multiply that one with the chloride ions. How many chloride ions are there? 2. So the answer comes out to be 5 times 10 to the power minus 3. Then for B part, it's going to be 0.15, that is the molarity of NaCl, times it with the volume, that is going to be converted into liter, 0.010, times with the 1, because chloride ions in NaCl is 1. So that comes out to be 1.5 times 10 to the power minus 3. And for C part, we have to multiply the molarity 0.20 times with the volume, that is how much? 0.020 times with the chloride ion, that is going to be 2 there. So it comes out to be 8 times 10 to the power minus 3. Then for D part, it's going to be 0.10 times with the volume 10 divided by 1000, that is 0.010. Okay, and then we have to multiply the with the chloride, and in KCl it's going to be 1. So the total answer for this one, that comes out to be 1 to the power minus 1 times 10 to the power minus 3. So the greatest number of moles are going to be this. So our option is going to be C. So in this question they are saying a sample of cyclohexene contaminated with cyclohexanol is separated by column chromatography. Hexene is used as a mobile phase and silica gel is used as stationary phase. Which statement explain why cyclohexene has a shorter retention time than cyclohexanol? So basically there is an oxygen atom in silica. Silica is what? That is SiO2, that is also called as sand. Oxygen in silica has lone pairs, and those lone pairs that are available to form hydrogen bond with hydroxyl hydrogen of cyclohexanol. So what happens? There is going to be the stronger attraction of, and that is why there is stronger attraction for the cyclohexanol with silica SiO2. So it does not travel as far as cyclohexene. So what happens? Cyclohexanol has a longer retention time and cyclohexene has a shorter retention time. So because D option is going to be correct, that cyclohexanol can form hydrogen bonds with the silica gel. In this question they are saying an unknown di X is spotted on the separate piece of chromatography paper. Both papers are then developed in the chromatography chambers. The developed chromatograms are shown above. Based on the result of the paper chromatography experiment, which of the four dyes is most likely to be dye X? So if you see dye X, it has traveled almost 1/4 of the paper. So its RF value is going to be around 0.25. And if you see this compartment, in this only B is the one which has traveled almost like 25% of the paper. So the right option is going to be B only. So die B is going to be the right answer because it has traveled almost the same distance as the X. In this question they are saying pentane has a boiling point 36 and heptane has a boiling point 98. A student obtains a mixture of the liquid pentane and heptane. They are basically in the mixture, they are mixed together, which are miscible in all proportions. Miscible means that they are soluble in all proportion. Which of the following technique would be best for separating the component of this mixture and why? First of all, you can see that there is a lot of difference in their boiling point. So because of the difference in boiling point and as two liquids are miscible into each other, so you can see one thing, that when there is a difference in boiling points, Then there is a technique which is called as distillation, that is considered to be the best technique, in which the liquid components are separated on the basis of their difference in boiling point, and this difference in boiling point is because of the strength in intermolecular forces. You can see as the number of carbon atoms increases, the number of electron also increase, so there is going to be the difference in boiling point because of that, and they are going to be separated due to the like difference in their strength of the molecular forces. So answer is going to be A. In this question they are saying in which condition is a solution most likely to form. So when you see option B, when solvent solute interactions are stronger than solvent solvent interactions, only in this condition a solution is likely to form, because what happens in this condition, the solute particles, they are surrounded by they are surrounded by solvent particles forming a solution. So our option is going to be B. In this question they are saying a 50.2 gram of barium hydroxide. So first of all you need to calculate the mole. Mole is equal to mass divided by molar mass. Mass is 50.2, and barium hydroxide is BaOH whole twice. Its molar mass is 171.35 divided by 171.35. So the answer comes out to be 0.292968. And then they are saying we have to calculate the mole of hydroxide in them. If we want to calculate the mole of hydroxide, so you can see in 1 mole of barium hydroxide there are 2 moles of hydroxide. So I have to multiply 2 with 0.292968, and that comes out to be how much? 0.585935. And then, as you know, I have to calculate the concentration. So concentration is going to be the molarity of hydroxide ions, and that is equal to mole divided by volume in liters, 585935, mole divided by liter, volume in liter, that is going to be 1.25, and that comes out to be 0.469. So right answer is going to be C. Azopic acid has a chemical formula C6H8O6. How many milliliters of 0.0653 molarity solution of azopic acid would be required to obtain 4.90 gram of azopic acid? So mass here is going to be 4.90 grams, and first I need to find out the mole. Mole is equal to mass by molar mass, so mole is going to be 1. Mole is equal to mass by molar mass, so 4.90 divided by molar mass of this one is going to be 176.12. that comes out to be 0.0278. So then it's going to be 176.12, and moles comes out to be 0.0278. And then molarity is given to me. Formula is molarity is equal to mole divided by volume in liter. So volume in liter, and now we have to find out volume in liter is going to be mole divided by molarity. Mole is 0.0278. Molarity is going to be 0.0653, and the answer comes out to be 0.426 liter, but we have to convert it into milliliters, so I'm going to multiply with 1000. So answer comes out to be 426 milliliter. Right answer is going to be B.